Dear students, welcome back to a new mathematics session. In today's session, we shall discuss the basic concepts of chapter 2, that is inverse trigonometric functions. Let's move on to the topic. Let's discuss what are inverse trigonometric functions. We have already learned about trigonometric ratios. Suppose let's take sine theta is equal to x, and if you take this sine to the right side, it comes as left side only theta, that is theta is equal to sine inverse x. We are taking sine to the right side, it comes as sine inverse. So theta is equal to sine inverse x. When we reverse this equation, we can write it as sine inverse x is equal to theta. Let's take an example. We already know that sine 30 degree is equal to 1 by 2. So this is an angle, 30 is an angle, and its unit is in degrees. So we have to convert this degree into radians first. Radians is another unit. So when we convert this 30 degree into radians, we have to multiply 30 into pi by 180. So when radians writing them, all the units or all the numbers will be changed in terms of pi. So for changing 30 degree into radians, we just multiply pi by 180. So we will get as 30 into pi by 180. When we calculate, we will get pi by 6. Or simply we can say pi is 180 means 180 divided by 6, that is 30 degree. So anyway you can calculate, either you multiply with pi by 180 and calculate, or else directly we can calculate, means 180 by 6 is 30 degree. Then sine pi by 6 is equal to 1 by 2, and here pi by 6 is equal to sine inverse 1 by 2, means pi by 6 is an angle in radians. Sine we are taking to the right side, it comes as sine inverse 1 by 2. So when we reverse this equation, sine inverse 1 by 2 is equal to pi by 6. So inverse of sine is an angle. So here you can see inverse of sine inverse 1 by 2 we have calculated, and we have got pi by 6, it is an angle. So we can come to the conclusion that inverse of sine is an angle. Similarly, inverse of all the trigonometry function is angle. Any trigonometric functions, there are 6 trigonometric ratios we have studied, starting from sine to cot. So all these 6 trigonometric ratios inverses if you take, we will get an angle. So here we must note that angle is measured in radians, not in degrees. Previously we have discussed here, when an angle is given to us in degrees, we have converted into radians and then we have calculated. So here all angle is measured in radians, not in degrees, and we write inverse trigonometry function as like this: sine inverse x, cos inverse x, tan inverse x, cosec inverse x, sec inverse x, and tan inverse x. There is another way of writing also is there. We write sine inverse x as arc sin x, arc cos x, arc tan x, and so on. This is the way of representation. Usually we use this type of writing, that is sine power minus 1 x, sine inverse x, cos inverse x, tan inverse x, like that, not this way. This is the usual way of writing. Next, we shall discuss domain and range of inverse trigonometric functions. In the first chapter, that is in relations and functions, we have already discussed about domain and range. Domain is the input value and the range is the output value. So domain is what goes in, that means input, and the range is what comes out, that is the output value. For inverse trigonometry functions, in the previous slide we have taken sine inverse sine theta is equal to x. From here theta we have got a sine inverse x. So here x goes in and angle comes out. So theta is equal to sine inverse x. Theta is an angle, sine inverse x. There x if you replace and put a value, that is the input, and sine inverse x answer what we get, that is theta, that is the angle. So diagrammatically if you represent theta is equal to sine inverse x, if you take here x is the input value, that is our domain, and sine inverse x will be equal to theta, that is an angle. So angle is the output value. So domain is x and angle what we get as the range. So domain is all possible values of x and range is all possible values of angles. So x is possible values of x is our domain, and all the output, that means theta what we get, that is the angle, it will be considered as the range. Next, we shall discuss the restricted domain and range of an inverse trigonometric function. In class 11, we have learned the graph of a sine function. So y is equal to sine x. If you consider, the graph comes like this. There will be x-axis and y-axis. In x-axis, we have start from 0, next to pi by 2, next 2 pi by 2. 2 pi by 2, when you cancel 2 and 2, will get us pi. Next is 3 pi by 2, next to 4 pi by 2, that is 2 pi. Next is 5 pi by 2 and goes on the right side. And on the left side, the same values with a negative sign. And in the y-axis there will be -1 and 1. And when you closely observe this graph, you can see there the graph is touching at 0 at different times. Here also it is touching at 0, here also it is touching at 0, here also at 0, and here also it is touching at 0, and here also the same. That means f of 0 is equal to 0, f of pi is equal to 0, f of 2 pi is equal to 0, f of minus pi is equal to 0, f of minus 2 pi is equal to 0, and so on. Means it is quite clear that the graph is not 1 1. Means the relation y is equal to sin x is not at all a function when you consider the entire graph. And if you define this relation from R to R, real to real, your codomain R, if you consider the codomain R real numbers, and if you consider an element 2 from the y-axis, you can see here if 2 is there, means there is no connection with 2 in the graph. That means 2 is not having any pre-image. That means it is not on 2 also. So if you consider y is equal to sin x as a whole, it is not a function. So if you want to get an inverse of sin x, it should be invertible. It should be invertible means it should be 1 1 and on 2. If you consider the entire graph as it is, this is not 1 1 and 1 2. So for our inverse purpose, what we do is we will restrict the domain as well as the range. So before discussing the domain and range of, or the restricted domain and range, let's try to draw the graph of y is equal to sine inverse x. It's quite simple. Just reverse the graph. That means what is there in the x-axis, it will come to y-axis. What is there in the y-axis, it will come to the x-axis. That's all. So the inverse function graph will come as it is. That means in the y-axis we have marked -1 and 1. That will come to the x-axis, that is -1 and 1. And in the x-axis, the pi values we have plotted, that will be coming here on the y-axis, like 0, pi by 2, then pi, 3 pi by 2, 2 pi, and 5 pi by 2, and so on. And so this is the graph of y is equal to sine inverse x. Now we are going to restrict the graph to a particular portion. That means this portion only we are going to consider. That means from minus pi by 2 to plus pi by 2, and also from x-axis -1 to 1. So when you consider only this portion, it is quite clear that this portion is 1 1 as well as on 2. Means only one input we will be getting only one output, as well as all the elements in the codomain will be having pre-images. That means if you consider only this one, that means if you restrict the graph only to this portion, then the graph is 1 1 on 2, and the function, the relation is a function and it is invertible. That means inverse exists. So here we have to find out the domain and range. So domain is what input we gave. That means -1 to 1 x values. -1 to 1 is our domain, and the range is between minus pi by 2 to pi by 2. So this is the domain and range of sine inverse x. That means restricted domain and range. That is, domain is -1 and 1, and the range is minus pi by 2 to pi by 2. Next we shall discuss the restricted domain and range of cos inverse x. First of all, let's recall the graph of a function cos x. Y is equal to cos x. As before, x-axis marking will be 0, then pi by 2, then 2 pi by 2, then 3 pi by 2, 4 pi by 2, 5 pi by 2, and so on the right side, and negative values on the left side. And y-axis from -1 to 1. Here also y is equal to cos x, the relation is not 1 1, because at multiple places here we are getting 0, and here also we are getting 0, and here also we are getting 0. So the function is not 1 1 as well as not 1 2. If you take another point on the y-axis, r to r if you define, and if you take 2 here on the y-axis, 2 is not having any pre-image. So this is not 1 2 also. So we have to restrict the graph, and for restricting, first let's draw the graph of cos inverse x. As I said before, for drawing the inverse function, just change the axis, that's all. So it looks like this. Y is equal to cos inverse x. Your y values between -1 and 1 will be marked here on the x-axis, and the x-axis values will be marked here on the y-axis, and the graph comes like this. And here we have to restrict the graph from 0 to pi. This is the portion we are going to restrict, and as before, the input or the domain will be x values -1 and 1, and the range will be between 0 to pi. That is, range we have to mark as 0 to pi. So for cos function, domain is -1 to 1 and the range is 0 to pi, both inclusive. Next, for the tan function, the graph is like this. Y is equal to tan x, and on the x-axis, as before we have marked, and y-axis it is real numbers. That unlike the previous one we have marked only from -1 to 1, but here all real number values are there. So when you consider the inverse, it comes like this, and we have to restrict the graph only the first portion, that is passing through the 0. This is the portion we are taking as the restricted portion. So by using this portion only, we will define the inverse of tan, that is tan inverse x. Here domain is R. Domain, when you check the x values, all real numbers are there. Domain is R, and range is from -pi by 2. -pi by 2 means from here it is -pi by 2 to +pi by 2, but not inclusive. -pi by 2 and +pi by 2, if you take also, it is not inclusive. It means both are not included. -pi by 2 also we cannot take, pi by 2 also we cannot take, but the values in between these two, because here the graph is very close to -pi by 2 but not touching pi by 2, -pi by 2. Here also same thing, the graph is very close to +pi by 2 but it is not touching +pi by 2. So it is from -pi by 2 to +pi by 2, the range. Next we shall discuss the principal value branch of cosec inverse x. For that, first let's recall the graph of cosec x. So this is the graph of cosec x, and as before, x-axis and y values we have taken, and we have plotted the graph like this. And when you take the inverse of cosec, that is cosec inverse x, if you consider, the graph will be coming like this. And here we have to restrict the values like this, means the graph, this portion we will be taking from the first quadrant, and from the third quadrant we will be taking this one. By using these two portions, we will be defining the domain and the range. So here the domain is R -1, 1. So when you consider x values, the entire real number system, entire R is there, but -1 is not included and +1 is also not included. So this portion is having gap here. So that's why R minus exclusive means we have to exclude -1, 1. R -1, 1. And then here the range is from -pi by 2 to +pi by 2, but 0 is not included, -0. So -pi by 2 to +pi by 2, we have to exclude 0. So this is the range. Next we shall discuss the principal value branch of sec inverse x. For that, the graph of sec x first we have to draw. Then by using this graph, means when you reverse this graph, we will get sec inverse x graph. Then here the restricted portion we have to mark, that is this portion and this portion. So by using these two portions, we have to define the domain and range. So domain is R -1, 1. Domain is this x values, so entire R is there, but -1, 1 is not included. So here you can see -1, it is very close to -1 but not -1, just not touching -1. And here also it is very close to 1 but not included. So R -1, 1 is the domain, and the range, when you consider, it is 0 to pi. So here you can check, 0 is this one and up to pi is there, but pi by 2 is not included. Means you can see the graph here just close to pi by 2 but not touching pi by 2. So 0, pi both inclusive, minus pi by 2. Pi by 2 is not included. Next, we shall discuss the domain and range of cot inverse x. For that, the graph of cot x is here, and when you consider the reverse of this one, we will get the graph of cot inverse x. And here the restricted portion is this one, and by using this portion, we will be defining the domain and range. So here domain is entire x-axis value, that is real numbers r, and range is 0, pi. You can see here range, when you consider the graph is up to pi, it is there, but it is not touching pi, it is very close to pi. So exclusive, we have to exclude pi. So 0, pi, and here also when you consider 0, it is not touching at 0, just very close to 0. So range is 0, pi, but not included 0 and pi. Open interval 0, pi. So these all principal values, its domain and range of inverse trigonometry functions, you need to by heart it, and the graphs are shown here just for understanding purpose. Now let's summarize what we have learned so far about the domain and the range. Range means principal value branches, means the restricted range. So here for y is equal to sine inverse x, the domain is closed interval minus 1, 1, and the principal value branch or the range is minus pi by 2, pi by 2. For cos inverse x, domain is closed interval minus 1, 1, and range is closed interval 0, pi. And for cosec inverse x, the domain is r minus 1, 1, and the range is closed interval minus pi by 2, pi by 2, excluding 0. Then y is equal to sec inverse x. For sec inverse x, domain is r minus 1, 1, and range is closed interval 0, pi, excluding pi by 2. And for tan inverse x, domain is r, and range is open interval minus pi by 2 to pi by 2. And for cot inverse x, domain is r, and range is open interval 0, pi. So how to recall this domain and range easily? In the sense, you can just draw the x-axis and y-axis, and we can mark 0, pi by 2, pi, and minus pi by 2. And means 0 to pi on the x-axis and minus pi by 2 to pi by 2 on the y-axis. And this axis divides the plane into 4 pieces. Each one is called quadrant: first quadrant, second quadrant, third and fourth quadrants. And you can check sine inverse, cosec inverse, and tan inverse. You can check here sine inverse, cosec inverse, and tan inverse. It's are between or lies in the fourth and first quadrant, means minus pi by 2 to pi by 2, here it is included. So it will be between minus pi by 2 and pi by 2. It's not exclusively minus pi by 2 and pi by 2. Here when you check here cosec inverse, it is minus pi by 2 to pi by 2 minus 0. 0 is excluded here. So while it is easy to remember, but while writing time, as a result, you must keep in mind these changes. And the remaining 3 inverse functions, that is cos inverse, secant inverse x, and tan inverse x. You can check here cos inverse, it is between 0 and pi, and secant inverse also between 0 and pi, but pi by 2 is excluded. And here for cot inverse, it is open interval 0 and pi. Of course 0 and pi we can recall, but the changes you must remember. Here closed interval 0, pi, and here closed interval 0, pi, but pi by 2 is excluded, and here open interval 0, pi. So this is between 0 and pi, means the first quadrant and the second quadrant. So this is one way of recalling these principal value branches easily, but not included the changes here. All the changes are not included, but you can find out your own way to recall these principal value branches, means domain and range of inverse trigonometric functions. Next, we shall discuss the exercise problems. First question from the first exercise: find the principal value of sine inverse of minus 1 by 2. Here we are asked to find out the sine inverse of minus 1 by 2. Remember, this is a very easy calculation, but little bit care we have to keep while solving. So let's take this given function as y is equal to sine inverse of minus 1 by 2. And from here, if you take sine inverse to the left side, it comes as sine. So sine y is equal to, we are taking the sine inverse to the left side, it comes as sine, already there is y, so sine y is equal to right side only minus 1 by 2. A bit of rough calculation. We have already learned in the smaller classes that for a particular value of sine, a particular value of angle, the sine of that angle is 1 by 2, excluding this minus sign. Okay, 1 by 2. So here we have learned, previously we have learned sine 30 is equal to 1 by 2. For 30-degree angle, sine value is 1 by 2. Then, as we have discussed before, 30 is in degrees. So we have to convert this 30 degree into radians. Just multiply with pi by 180. So just to multiply the given degree angle, that is 30 with pi by 180, and here 30 and 180 can be cancelled 6 times, so we'll be getting as pi by 6. So this is only the normal way of calculation. If you do mental calculation also, no problem. Sine 30 is equal to pi by 6 directly also we can write, because pi is 180, 180 by 6 is 30 degree. The mental calculation also you can do, it's not a problem. And let's go through the table here. Here sine inverse of minus 1 by 2, here there is a negative sign. So if there is a negative sign along with the sine inverse, what we have to do is, your angle also carries a negative sign. That means we have to take minus pi by 6. So you will be getting the answer as sine y is equal to, instead of minus 1 by 2, will be getting as minus pi by 6. That's what it is written here. So range of principal value of sine inverse is between minus pi by 2 and pi by 2. Here range we have already discussed in the previous slides through graphs. The range is between minus pi by 2 and pi by 2. What value we have gotten as? We have got as pi by 6. Pi by 6 means it is 30 degree. So 30 degree is between minus 90 and plus 90. Here pi by 2 means 90. So surely 30 degree is between minus 90 and plus 90. So we can conclude that the principal value is minus pi by 6. Next, question number 2. Find the principal value of cos inverse of root 3 by 2. As before, let's take this one as y. So let y is equal to cos inverse root 3 by 2. The next step is take this to the left side, cos to the left side, cos inverse to the left side. So it comes as cos y. Cos y is equal to root 3 by 2. So we have to recall the trigonometry value table. There a particular angle for cos of a particular angle is root 3 by 2. So we have to check which angle is that. So we know that cos 30 is root 3 by 2. Again, this is in degrees, we have to convert it into radians. As before, we will get as pi by 6. Now you can check the sign here, it is positive. So for cos function, if it is positive means angle also will be positive. So we will be taking only pi by 6. So cos y is equal to cos pi by 6 we have written. Next we have to check whether this pi by 6 is within our range or not. So for cos inverse function, the range is between 0 and pi, between 0 and 180. Between 0 and 180 means here pi by 6 we have got. A pi by 6 is 30. So 30 is surely in between 0 and 180. So here, while keeping in radians, you may feel difficulty whether this is within the range or not. So instead, if you convert this one into degrees, pi by 6 means 30 degree, and here pi means 180 degree. So when you consider that way, it will be easy for you to identify. So we know that the principal value of cos inverse is here 0 and pi, and surely this pi by 6 is included here. So the principal value of cos is pi by 6. So remember this range and principal values and all, you need to by heart it properly, because no table will be available while solving these type of questions in the examination. Next we shall discuss question number 3. Find the principal value of cosec inverse 2. As before, let's take this one as y. So y is equal to cosec inverse 2. Take cosec inverse to the left side, will come as cosec y is equal to 2. Again, we'll go for rough calculation. For a particular value of an angle, cosec of that particular angle is 2. So here sine 30 is 1 by 2. That is easy for us, because sine, cos and tan, it is easy for us to remember. So if sine is there, surely we will be able to calculate cosec. So sine 30 is 1 by 2. 1 by sine 30 is cosec 30. So cosec 30 means we just take the reciprocal of 1 by 2. Reciprocal of 1 by 2 is 2. Then change into radians. Theta 30 degree means 30 into pi by 180, that is pi by 6. While doing 2-3 questions, it will be quite familiar for us. We can also write directly this one. Then just go through the table here. The angle is the value given to us is positive. So for cosec, if the value given is positive, means your angle also will be positive. So we will be taking as cosec y is equal to cosec pi by 6. Then we have to check whether this is within this range or not. So range of principal value of cosec inverse is minus pi by 2 comma pi by 2 excluding 0. So here pi by 6 means 30 degree. Surely 30 degrees in between these minus 90 and plus 90. So of course 0 is not included. So we can write, or we can conclude, the principal value of cosec inverse 2 is pi by 6. Next we will go with the question number 4. Find the principal value of tan inverse of minus root 3. So here there is a minus sign. Let's take as y is equal to tan inverse of minus root 3. Then as before, take this to the left side. Tan inverse will come to the left as tan. So tan y is equal to minus root 3. Then again we have to use the table to calculate. That is tan 60 is root 3. So when you take tan 60 is root 3, in the sense just this degree we have to change into radians. That is theta is 60, multiply with pi by 180 will be coming as pi by 3. Then we have to check the sign here, tan with the minus sign. Tan with the minus sign means you have to take the angle as minus theta. So we have to take this one as minus pi by 3. So we will be written this as tan y is equal to tan of minus pi by 3. We have got here pi by 3. Since here there is a minus sign, you just put a minus here. So tan of minus pi by 3. Then this minus pi by 3 we have to check. The range of tan function is between open interval minus pi by 2 to pi by 2, means minus 90 and plus 90 open interval. So here pi by 3 means it is 60. So surely it is included here. So the range of principal value of tan inverse is open interval minus pi by 2 comma pi by 2, and the principal value is minus pi by 3. What we have got here is minus pi by 3. Next we shall discuss question number 5. Find the principal value of cos inverse of minus 1 by 2. Here given to us cos inverse of minus 1 by 2, let it be y. Y is equal to cos inverse of minus 1 by 2. Take this cos inverse to the left side. So cos y is equal to minus 1 by 2 will be getting. So there is a negative sign. You have to take little bit care while calculating. So for a particular angle of cos, there is answer we are getting as 1 by 2. So we have already learned that cos 60 is 1 by 2. So this table of values, as I mentioned before, if you are not familiar, you need to by heart it, or you have to recall and write it. You can derive also, it's not a problem. So whichever way is convenient for you, that way you can follow it. So cos 60 is 1 by 2. 60 is in degrees, we have to convert it into radians. That is multiply with the pi by 180. You will be getting as pi by 3. Now it is shown here there is a negative sign. So negative sign means its principal, it is cos inverse. If it is negative means the principal value is pi minus theta. So we have got theta as pi by 3. So again we have to do pi minus this angle pi by 3. So pi minus pi by 3, when you do the calculation, 3 pi minus pi, that is 2 pi. The common denominator is 3. So we will be getting the answer as 2 pi by 3. That is cos y is equal to cos of 2 pi by 3. So here the difference is this one, we have to subtract from pi. So we have got cos y is equal to cos of 2 pi by 3. Range of principal value, that is between 0 and pi, both are inclusive. So surely 2 pi by 3 is in between these two. So the principal value is 2 pi by 3. Next is question number 6. Find the principal value of tan inverse of minus 1. It is a quite simple question. Previously also we have done the similar type. So let it be y. Y is equal to tan inverse of minus 1. Take this tan inverse to the left side. Tan y is equal to minus 1. Then as we know that tan 45 is equal to 1. Tan 45 means when you convert this one into radians, will be coming as pi by 4. So you have to check again tan. There is a negative sign means you have to, the principal value will be minus theta. So just to put a minus sign here. So tan y is equal to tan of minus pi by 4. Then as before, the range we have to write, it is between minus pi by 2 and plus pi by 2 open interval. So the principal value of tan inverse of minus 1 is minus pi by 4. Next we shall discuss question number 7. Find the principal value of sec inverse of 2 by root 3. Let's take y is equal to sec inverse 2 by root 3. Sec inverse bring to the left side. It comes as sec y is equal to 2 by root 3. Then we know that cos and sec are reciprocals. So better to take cos. Cos 30 is root 3 by 2. 1 by cos 30 is sec 30. So that is sec 30 is equal to, take the reciprocal of this one. Root 3 by 2 comes as 2 by root 3. Then 30 degree we have to change into radians. We will get as pi by 6. And let's check the table here. Sec with a positive sign. So here sec means the principal value is positive, means just theta itself will be coming. So pi by 6 alone we will be taking. That is sec y is equal to sec pi by 6. Then let's write the range of principal values of sec inverse is closed interval 0 comma pi minus pi by 2. So clearly pi by 6 includes here. So principal value of sec inverse of 2 by root 3 is pi by 6. Next, question number 8. Find the principal value of cot inverse of root 3. Let it be y. Y is equal to cot inverse of root 3 and cot y is equal to root 3. Take cot inverse to the left side. Then again, if cot is given to you, means tan we can take, that will be easy. Tan 30 is equal to 1 by root 3. If you know cot directly also you can put, it's not a problem. Here if you don't know, tan taking is better. So tan 30 is equal to 1 by root 3. Reciprocal of tan 30 is cot. So cot 30 is equal to reciprocal of 1 by root 3. That means root 3 by 1, that is root 3 itself. 30 degree we have to convert into radians. We will be getting as pi by 6. We have done several times this calculation, so it will be easy for us. Directly also we can write. So next we have to check the sign here. Cot with a positive sign, angle itself will be coming pi by 6. So cot y is equal to cot pi by 6. Then next write the principal value of cot, that is open interval 0 comma pi. Pi by 6 is 30 degrees, so surely between 0 and 180. So the principal value is pi by 6. Next we need to solve question number 9 and question number 10, and these two questions we will try it as homework. Dear students, today we have discussed the basic concepts of inverse trigonometry functions and the restricted domain and range of inverse trigonometry functions, and also we have solved first 10 questions from the first exercise. I request all the students to go through the formula and recall the formula and by heart it, and solve these 10 questions independently in a sheet of paper. While solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.